Today in this video we are going to see about the working principle and characteristics of ACR. So what is meant by ACR? ACR is a flow layered 3-junction semiconductor device used for controlling high power in electric circuits. It acts as a controlled switch. So it is normally your high power handling is done using latching behavior. Both combined together is called as silicon controlled rectifiers. So the conduction behavior will be like in such a way that it conducts only when it is being triggered by a gate pulse, and it remains on as long as current exceeds the holding threshold. It cannot be turned off by the gate alone. So this is the anatomy or the internal structure of the ACR. So if you see, it has two PN junction, PN junction. It is made up of these layers, and the terminals it has are anode, cathode, and gate. Gate plays the major role in case of ACR. So this is a 2-model transistor. So it is very much useful to understand the latching mechanism, which is being a special feature in ACR. So if you see that in the diagram, we have mentioned as an arrow mark in the gating pulse. So the trigger is done only it fires the other end of mutual base collector. So feedback is created in order to produce an infinite self-sustainable cycle. So based on that initial gate signal, the internal feedback is maintained throughout the conduction of current when the current drops below the holding threshold. So these are the operational states of ACR. There are 4 types of operational state: forward blocking state, triggering state, conduction state, and reverse blocking state. In forward blocking state, the anode is positive with respect to cathode. The junction J1 and J3 is being forward biased, and J2 remains the reverse bias. So still ACR will be in off position, only the leakage amount of current will be flowing. So once ACR is ready to conduct, okay, the small amount of leakage current will be flowing in this stage. So ACR is waiting for its triggering state. It is ready to conduct. And if once it is being turned on by applying the gate pulse, the increasing voltage above the breakdown voltage is occurred, then it will trigger it. So the next state is the triggering state. A positive gate pulse is being injected into P2, which reduce the J2 barrier, and device state will be transition is on. Next stage is the conduction stage. In this stage, the latching occurs. So the SCR receives the positive gate pulse through the junction J2. The J2 is being forward biased. So the large amount of current flows between anode and cathode. So the SCR acts as a closed switch, and it started conduction. So the voltage drop across the ACR will be very, very small, and the gate losses controls after the triggering. So in order to turn off, the SCR will turn off only when the current falls below the holding current. It will hold some amount of current inside the loop. So when that particular holding current is below, then only the conduction will be reduced. So next stage is the reverse blocking stage, which is an off state. So the anode is connected to negative with respect to cathode. The junction J1 and J3 is reverse bias, and J2 is forward bias. Here also only the small amount of leakage current will be there, and the SCR entirely blocks the reverse flow until the breakdown voltage is received. So this is the 4 operation step which is being followed in the SCR. It will once we apply the gating pulse only, it will start the conduction process. Till that, it will be waiting for the triggering state. This is the VI characteristics curve of an SCR. When we are applying the gate current, shift breakover voltage to the left. So normally the forward breakover current is being shown in the figure VB0, and the holding current is being mentioned as a dotted line. In the reverse block also, the holder current will be there, and a peak reverse blocking voltage is also mentioned in the VA characteristics of the SCR diagram. So coming to the advantage. So SCR have a multiple advantage like high power handling, high efficiency, fast switching, reliable operation, simple triggering, etc. In case of, since the anode and cathode, after triggering state, large amount of current flow through it, they effectively manage the damaging of electric loads. So as the energy loss is very less during the operation of SCR, the efficiency is obviously very high, and it also allows for a quick response time in application. And also in case of reliability, it ensures the constant performance over time. Triggering mechanism is very simple and which makes CET integration with other systems. So even though it has multiple number of advantages, it has few disadvantages too or limitations. So we cannot control the gate current, and it is a unidirectional device. So SCR will conduct in the current only in one direction. The SCR switches even though it has fast switching speed, in modern electronic devices when you are using SCR, the speed is very slow. And the SCR operation in AC circuits introduced harmonics, which will affect the system performance, and the sensitivity to variations damages the SCR can damage by voltage and current variations. Obviously SCR needs a heat sink in order to manage the thermal management within our electrical circuits. So these are the applications where SCR being used. AC to DC conversion, motor speed control, light dimmers, heat and temperature control, inverters and converters, and then over voltage protection. In these areas, SCR plays a major role. Hope in this video you'd have understood what is meant by SCR, what is its layer, what are the operation stage which are available in the SCR, its applications and disadvantages and advantages. Thank you.